So let me talk about the next feature, which is a test grouping. Artos supports two levels of test grouping. One is at the test case level and the other one is at the test unit level. So how do you use it? So Artos supports the annotation called a group, and using the group you can assign a group name to either the test case or the test unit. The group name can be formed using any simple string, and it is case insensitive. So you can either separate test cases within the category of fast or slow, regression or long running. You can make it a good path or bad path. You can either separate them using a release number or the year or date. So how do you group them? That is completely up to you. But in current example, what I have done, I have separated all the test case within a group called fast or a slow, and within the test case all the test units I have separated them with a group called good path or a bad path. So if I show you, so this one is all the fast running test case and they are all good path, and in this test case I have two groups assigned. One is called slow and one is called ABC, and then these has a two units. One is a bad path and the other one is a good path. So how you group them, it's completely up to you, but let me show you how you can use this group filtering very smartly. So as you can see in my feature runner example, I'm going to add these two new lines. So if you add these list, set test group list, and keep them as a star, that means you are saying please don't apply any group filtering. So star means run everything. Same way you can do that at the unit level, that you can say please run everything. So either you specify star or you comment those two line out, which means you are telling the runner that I don't want to apply any group filtering, please run all of them. But let's say you want to filter the test case according to the group. So if I want to filter the test case only in the, let's say I want to say only run the fast running test case, so we don't waste our time. And as I said, it's a case insensitive, so you can make it capital or small, doesn't matter. And I would like to say please only run good path units, right? So I'm going to just say good path here. So if we now execute this runner, you will see that it only picks up the fast running test case. So you can see some of the test cases are missing in between, and that's purely because it's grouping under the only fast test case and dropping all the slow running ones. So if I execute that now, you would see that it only runs only good path units, so there are no failures in this test case. Now let's say if I say please run also the bad path test cases, right? So let's call it bad path. That means now it is not only going to run units which are labeled as a good path, it will also run some bad path units. And as you can see now, they have two test case failures and they are all listed here. So grouping is very powerful feature, and depending on how you use it, you can use it to either filter test cases or choose to skip some test cases based on some smart logic. The other thing you would notice that the way these lists work is that any group name that you specify, it is applied as a OR method, right? So that means any test case belongs to good path or a bad path, it will be taken as the one you would like to execute. But what if you would like to run maybe AND logic, or what if you would like to run only the groups which maybe starts with G or B or just says bad somewhere in between the group name? So that's why we also supports a regular expression. So instead of specifying the string name, you can specify Java regular expression here, and then the test case will be filtered using that regular expression. So these will give you these extra power to do maybe more complex filtering. The other thing you would notice that even at the test script level, you can specify the test case group or the test unit groups, and these also supports the regular expression. So you can just put your regular expression here as a string and it will filter it accordingly. So this is how the test grouping works. Let's talk about test skip. So there are many different reasons people would like to skip the test case. So one of the reason could be that the test case is failing for any reason and you don't have time to investigate, so you want to maybe just temporarily disable it. You may want to skip the test case because it's no more relevant, and you don't want to delete the code, but you don't want that test case come in your way. Third reason could be that you want to dynamically skip the test case after making some decision while the code is running. So we support multiple way of skipping the test case. So one smart way you can skip the test case is using the group annotation. So if you group test case under right categories, then you can say only run particular group and not the run other. So that's one way to skip the test case. There are times where you can't always skip them smartly with the test group, so you want to forcefully disable it. So if I show you the example here, within the test case annotation we have attribute called skip, and you can label test case with skip equals true. If you do that, then even though the test case maybe belongs to a group or it's all valid construction, the runner will completely ignore it, because as a user you are saying explicitly that please skip that test case. So if I just disable all the grouping to make sure that all test case will be picked up, you would notice that that particular test case, which is a sample test case 2, will be missing from the list. So you can see here that 0, 1 and then 2 is missing, and then rest of the test cases are there. So this is how the skipping works on the test case level. Now let me show you the similar thing you can do at the unit level. So in this test case, we have 3 units. They all valid constructions, but I have added a skip equals true attributes in the unit annotation. So what will happen, that this test case will appear in the execution list, but when you execute that test case, these 2 unit will be skipped. So let's see how it works. So if I just comment out all these before after so it doesn't pollute the logs, and then if I now execute the test case and let's just run only sample 3, you would see that it only ran test unit 3, right? So test case started here, it only ran test unit 3, and it didn't even talk about the first and second unit because we have explicitly said please skip those units. So this is how other way you can use skip. There are a few other ways. So for example, let's say you have a sample test script and you only specify few of the test cases, then obviously you are telling the system that please skip the rest of it. So this is another way of explicitly skipping the test case. Now there is a time when you can't decide upfront that you want to skip that test case or not. You may want to run some test logic, and depending on the reaction of the product that you are trying to test, you may choose to skip it at the runtime. So how do you achieve that? So we also support a test status called skip. So to do that, let me just write a fake code. So let's say we want to say if 5 is greater than 4, which we know it's true, then we want to skip this unit, let's say, for example. And in that case you can just set the status. So you can also add some comments here. You can say skipping because we do not need to run any further, right? So if I execute this test case now, you will see that one unit will run successfully as a pass and the other one you will be marked as a skipped. So let's just run that simple test case, and once you execute, you will see that one unit has passed and the other one unit has been skipped, and the status is propagated to the test case, so the overall test case is marked as a skip. So this is how you can skip the test case at the runtime. While we are at the topic of skipping a test case, let me also highlight the use of GUIitA Selector. So why did we need that in the first place? So as a Artos team, we recognize that when you are in a debugging or development environment, you may want to run some test case out of order, or only run selective test case, or sometime rerun the same test case, let's say 50 times, just to reproduce some issue. And to achieve all that, if you keep touching the production test script or the runner class, there is a high chance that you will do a typing error or commit the code which is not ready for production, and then you end up spending more time in debugging later on. So we wanted a feature that can let us achieve all that without touching the production code. So this is how the GUIitA Selector came into existence. So as you've been noticing that every time I run any test suite, the very first thing it does, it shows you the GUIitA Selector. In this GUI, it will highlight all the test case that you are going to be running. It also shows you the sequence that you have assigned. It tells you the total number of test case that you will be running. You can choose to run all test case, or you can be selective about the test cases and you can execute them, right? You can also change the loop count, which then you can run the same test case, let's say 10 times. And at the same time, it preserves the dependency. So it won't let you rearrange the test case. It will always keep the test case in the given sequence, but you can choose to just run some or the other, right? So there are many advantages of having GUIitA Selector, but we also understand that GUIitA Selector is not an requirement for all the environments. So if you are already in the production environment, you might not want to have GUIitA Selector popping up because you might not have a user there to press the execute all button. At the same time, if you are running it on a build server or some other environment where the GUI components are not supported, you may want to disable that. So to do that, you just go to framework configuration.xml file and find this flag called enable GUIitA Selector and set that as a false. Once you set that as false, GUIitA Selector won't appear and you can run it like any other test framework. Next feature I would like to talk about is a test timeout. So let me show you the sample test case 4, which is designed to demonstrate test timeout feature. As you notice the line 24, where unit annotation also supports this attribute called test timeout, and we have set the test timeout equals to 5000 millisecond. So what does that mean? So that means that users expectation for the total execution time for that particular unit is only within the 5000 millisecond. So if test execution took more than 5000 millisecond, then that particular unit will be marked as a fail. And this is all done by the runner itself, so user doesn't have to worry about it. User can just simply set the time that they expect, and then runner will look after the rest. The other thing to note here is we have two units here. So even though the first unit will be marked as a fail because we have purposefully set the thread.sleep equals 5500 millisecond, which is higher than the expected, you will see that the second unit will still run successfully. So the test timeout can fail the test case, but it doesn't impact the next running units. Other important thing to note here is test timeout can only be applied at unit level, so you can't apply that on the test case level. So let's run that and see what happens. So if I just run that simple test case, you can see we are waiting for 5.5 seconds now, and then the result will be in the log file. So what is happening here, that the first test unit took more than 5 seconds, and that's why it was force marked as a fail, and the second test unit ran successfully, that's why it's marked as pass. So we now know that the test timeout also works, and it's very powerful depending on what kind of testing you are doing. While we are at it, let me also highlight another tiny feature that generally people fail to consider, but it's very important, which I call the fail stamp injection. So what Artos does is, as soon as test is marked fail, it could be either by the runner itself or it could be user itself setting the status equals fail. Artos will straight away inject this fail stamp in the log file. So what it helps us in achieving is that it helps our debugging really fast. So there are cases where our test case prints like thousands of lines of code, and it will be really hard to find the exact line of failure, and then we have to read the test script and go line by line to see where exactly the failure occurred. So by having this fail timestamp, by having these fail stamp, we can find the exact line of failure really fast, and it speeds up the entire debugging or development cycle. So now you know two features. One is the test timeout, and one is the fail step injection using the Artos. Let's move on to the next feature, which I call known to fail. So before I explain to you how that feature works, let me tell you why that feature is in existence in the first place. So we encounter many scenarios where we raise the bug and bug do not get fixed for a long time, either due to the priority calls, or developer thinks it's not worth fixing right now, or the program manager do not allocate time for that. In that case, if we leave that test case within the suite as it is, then it will keep failing and we have to keep reinvestigating the same issue. The alternative is that we track those sort of issues separately, but that's the extra maintenance. And also what can happen is developer may fix that test case without letting you know, intentionally or unintentionally. And because of that, you either find out when your test case fails that the logic has changed and you weren't notified, or you find out like after a few months and then you realize, oh, you weren't been updated, right? So how do we get around these scenarios? So we looked around many test framework and we couldn't find a single feature which can handle these sort of situations. So we came up with this new feature called known to fail. So let me explain to you how it works. So I have purposefully created a method called add, which takes the 2 integer value. The expected outcome is that it will return the addition of those two values, but just to create the bad path scenario, I'm purposefully returning the wrong value, right? So we know that this method always returns the wrong value, and I have created few unit test case here to explain to you how known to fail can work. So one scenario is where we recognize that this method is always going to fail, so then we want to mark it not as fail but as a known to fail, so then it segregates itself as a separate category and we don't have to reinvestigate that again. So the way we can do that is whenever we see the addition value is not matching our expectation, instead of setting a status equals fail, we can set the status equals to known to fail. But how does that help us, or how does it protect against a wrong flow? So let's say developer will fix these without letting you know, and in that case it will not enter these if statement and move out, and you would never find out that it actually not failing where it's supposed to fail now. So to protect against that, what we have created is this annotation called known to fail. So if you apply this annotation and mark this KTF equals true, that means you are telling the runner that we are expecting this method to be known to fail. So that means we must expect this method status to be KTF and not anything else. So if this method follows any wrong flow, that means it will not be set as KTF, and that means runner will recognize that and force mark it as a fail. So that way there is no escape for developer fixing that bug and you would not be able to notify, right? The other advantage of this known to fail annotation is that you can also mention your Jira reference. So it could be your bug reference. If you are using Jira, then your Jira ticket number, or any other system that you are using to track the issues. So you can mention that here, and it could be many of them. You can just create a comma separated list. So once you have provided that list, and let's say the scenario where the test case will fail because someone tried to set the wrong status or it did not follow the right flow, in that case the summary log file would also print this ticket number, so that way it will help you find those bugs faster and you can raise it again. So let me run this test case and I can show you how it appears. So you will notice that the first test case will be marked as known to fail because we are setting status known to fail. So it satisfies the requirement of known to fail equals true. In the second unit, we are trying to mark that test case equals pass, but because the runner will be checking for known to fail, it will actually force fail this test case. And in the third test case, we have disabled the known to fail force check, and that means we can set the status equals pass and it won't complain. So let's run this scenario. So we'll only run one test case, which is known to fail, and as you can see that the test unit first, because it was marked as known to fail, it just went through fine. The second test case, which was marked as pass, but because that means known to fail test passed, which will make runner to force fail this test case, and that's why the outcome of the test unit is fail. So you can see all the information for you to figure out what happened. And third test case, because we disable the known to fail check, it successfully passed. So if you look at the total count here, so we executed one test case and 3 units. One of the unit passed, one of the unit is known to fail, and one of the unit is fail, right? So it makes sense. So let's look at the summary log file. So let's look at the log and look at the summary. So wherever the test case is fail or it's passed, you can see that it printed out its GUITA reference, right? So all the status has their GUITA reference against it. So that means if you want to find out your bug tracking tickets, you can quickly go to summary file and you will know what happened. So this is how the known to fail scenario can be used. And because now the known to fail is a separate category, you are not mixing it up with actual failures. So even to convince the management that we have clean fail versus bugs that we know it is going to fail, we can segregate them separately. The next feature I would like to talk about is expected exception. So let's say you have a test case which may throw an exception and you know about it. So one way to handle it is you have a try and catch, you handle it, and then you can say this is expected exception, so don't fail it. But that will complicate the code. So let me show you with an example how it would look like. So if in typical scenario, if you know that you are trying to parse this integer, so a string is trying to be passed as an integer and it will throw the number format exception. So what you would typically do is you have a try and catch and you say, okay, if you see number format exception, it is as expected, so please don't do anything. But that's just too much coding for achieving tiny thing, right? So to handle that, we have created this new annotation called expected exception. So what it allows you to do, it allows you to specify the exception class that you are expecting. And if the exception thrown by this test case or test unit is exactly the same class as you have specified, then the runner itself will consume that and just mark it as a pass or whatever the last status you have set, right? So as you can see that the complicated code that I just showed you before, which was that many lines, now just became very neat and tidy code where you are just doing a one line of code, and if it threw the exception, then you can just specify it as expected exception and everything will run happily. Now what if the scenario is where you can get one or more exceptions? So let's say there is a potential of getting either number format exception or some other kind of exception. In that case, you can also specify more than one exception in the same annotation. So if you look at the unit 2, that's an example of how to specify more than one exception. So if any of these exception arrived, then runner will consider that as a normal thing and not force fail it. Let's say the scenario where you are not just trusting the exception, but you also want to verify the description of the exception. So let's say the exception thrown is some handmade exception which has the description called this is the test code. So you handle that exception as the expected exception, and you also would like to verify the string, right? So you can also specify string using the attribute called contains, and it will match the string, and if string matches, then it will say okay, this is the correct exception with the correct description, so I'm going to consider that as a pass. Other scenario is, let's say your exception string or description is bit complex, or it contains the value that could dynamically change. So how do you match that? So we also support regular expression. So let's say you have some exception that you don't want to completely match, you want to just match that it, as long as it contains taste, I'm happy to consider that as a valid exception. So instead of specifying just a typical string, we have shown you the example that you can specify the Java regular expression, and what I'm checking for here is just look for something that has a taste in it, and expected exception is still specified, so these tastes will also be considered as a pass. You can, so let's say if you have a two exception and one can throw different description to other, you can also handle that with regular expression. So this is how the expected exception annotation works. Now important to remember here that as soon as the exception is thrown, so let's say if this line throws exception, it would straight away be terminated, and because you are passing the handle back to runner. But what if the scenario where you would like to execute a line of code after the exception has occurred? So in that case, we recommend to not use this expected exception annotation. You can continue using your old method, which is using try and catch, and just handle it, and then you can still continue running some extra line of code, right? But what you have to remember there is a possibility that exception didn't occur, and in that case, how do you protect yourself against that code? So we have also created another exception guard method called guard wrong flow. So if you put that in this line, and let's say the exception didn't occur at that line which you were expecting, it will carry on executing this line, and as soon as it will hit this line, it will throw another exception which will help you notify that now is following the wrong flow. So let me just execute these so you understand. So what are we expecting here? So we would see that this line will throw exception, but this test case will pass because we are specifying this exception. This line also will throw exception, but we are specifying two exception, and one of them will match, so it will pass as well. The third unit test will match exception and the description, and they both matches, so it will pass as well. The fourth unit, where we are trying to use regular expression match in the description, that will also be valid, so fourth unit test will also pass. The fifth scenario, where we are saying enforce equals false. So we are saying that if exception occurred, then please match one of these exception, but if it didn't occur, I don't want to force fail the test case. So in that case, we can just set another attribute called enforce equals false, and that way if exception didn't occur, it will still be considering this test unit as pass. So unit 5 will also pass, and unit 6 will also pass because we are handling this exception here, right? So let's see how it runs. If we run this sample 7 expected exception, you can see that all of the scenario has passed, and you can see that Artos runner puts out quite a descriptive information that it matched the exception, which exception, and the description. If it is regular expression match, it will also spell that out. So it is very useful for user to follow what actually happened. So this is how the expected exception works.